The next method we're going to look at is the lattice method for multiplication. It starts with a rectangle that's subdivided into squares, and then we further divide it into diagonals, and then we add along the diagonals. So if we have the same number of digits in the numbers that we're multiplying, then we would just draw a square, and we don't have to worry about the placement of one number over the other. However, if one of your numbers has more digits than the other, that one should go at the top. So we're going to do the same 3 examples that we did with partial products. So we're going to do 9 times 67. We're going to do 39 times 45. And then we're also going to do 256 times 14. So I'm just going to start by showing the initial setup for all 3 of these, and then we'll actually go through and work them out. So for 9 times 67, since 67 does have more digits, I'm going to make sure that that goes along the top, right? So that means that I'm going to have 2 boxes going horizontally. 1 for the 6 and 1 for the 7. Notice that the placeholder zeros are not there, right? So I'm not going to worry about the fact that that 6 is in the tens place and it's really 60. I'm just going to split it up. And then if you want to put a little multiplication symbol here, you can, you have to. And then the 9, since it's just a single digit, means I'm only going to have 1 box going vertically. So this would be the setup for my lattice multiplication. So we'll work that out in a minute. Let's go ahead and set up the next one. So this one is a 2-digit number times a 2-digit number, which means it does not matter which one goes on top versus which one goes on the right-hand side. I am going to have a 2 by 2 though. So I'm just going to choose to put 39 at the top and 45 along the side, but that does not matter. Now we could go ahead in terms of our initial setup. We could probably go ahead and draw some diagonals here. And if you want to go ahead and extend them beyond the boxes, that's not a bad idea. So I'm going to draw diagonals that go from the top right to the bottom left, and then a little beyond at the bottom, right? So that's what that's going to look like with my diagonals, and you'll see how that comes into play shortly. All right, so then for 256 times 14, the larger one, or I should say the one with more digits, is going to go at the top. So this one, I have 3 digits times 2 digits, so that means I'm going to have 3 boxes horizontally. I'm going to have 2 boxes vertically. So I'm going to split up my 2, my 5, and my 6, and then my 1 and my 4, and I'm going to go ahead and draw those diagonal dividers going down and to the left. So this is my setup for these 3 problems, and now I'm going to go ahead and work through these 3. So the nice thing about lattice method is that it actually doesn't really matter what order you multiply. However, I will tell you that it does matter when you get to the adding step, what order you add them in. So I'm going to tend to do these right to left like we do with standard algorithm. And that's probably a good practice to start, but you technically don't have to. So technically, I could multiply, like if I wanted to start with this box and do 6 times 9 first, I could. So I'm going to go ahead and do 7 times 9, which is 63. And what I'm going to do is I'm going to split up those digits. So I'm going to put the 6 on one side of the diagonal and the 3 on the other. And then to find what goes in this box, I would do 6 times 9. So it's essentially an area model that's not just scale. 6 times 9 is 54, so I'm going to split up the 5 from the 4. So I ended up doing that right to left. You wouldn't have to. However, now I'm on my adding step. And when I do my adding step, I do need to do this in order in case there's regrouping. So I'm going to go ahead and add up these numbers along each diagonal. So let's say I start with the rightmost one. So this diagonal right here, I would add all the numbers in that diagonal. In this case, that's only 3. So that's just going to be a 3. And then the next diagonal would be this one. And so I would add those numbers. 4 plus 6 is 10. And so what I'm going to have to do is I'm going to have to write a 0 and then regroup my 1. And where we regroup this is in the top left half of the box, right? of the next diagonal there. So then I'm going to add what's in this next diagonal, which would just be the 5 and then also the regrouped 1. So that's going to give me 603. And if you want to check what we did on the previous page when we did partial products, you can check that we did indeed get 603. So then let's look at the next one. So this one, again, you can multiply in any order. Just make sure when you add that you do it in order. So I'm just going to start here. I know that that one is going to be 9 times 5, since there's a 9 across the top and a 5 across the side for that lower right box. So this is going to be 45. If I go on to this one, 9 times 4 is going to be 36. I'll go ahead and I'll do this one next. It doesn't really matter on my multiplication step. So this one is going to be 3 times 4, which would be 12. And then finally, 3 times 5 will be 15. So just notice how I'm splitting up those digits each time I do this. And now I'm going to add along each diagonal. And this one I absolutely do need to do from right to left. So starting with this one, that would just be a 5. If I add up the numbers in the next diagonal, 6 plus 4 plus 5 would give me 15. So I'm going to write a 5. And then I'm going to regroup right here a 1 for the 15. So for the 1 in the tens place there. Then I'm going to add these numbers in this diagonal. So 3 plus 2 plus 1 plus the regrouped 1 would be 7. And then finally, this last diagonal only has a 1 in it. So that's going to be 1. So if it's a little confusing, like how these are running along the side, it's probably good to go ahead and write your product out to the side. But you're basically just reading it like top down and left to right. And then let's do the last one. So I'm just going to go ahead and multiply, starting with the top left this time. So this box would be 2 times 1. Now 2 times 1 is 2. So what's important here is to go ahead and write a 0 in the top left half of that box. So kind of like we would do with dates. A lot of times, like if you're talking about February 16th, they won't let you put 2/16. They make you put 02/16 in some forms. So whenever we get a single digit number, we're going to make sure we put a 0 in front of it. All right, so then if I want to do this box next, that's going to be 5 times 1, which is 5. So I'm going to put that in as 0, 5. 0 on the left and 5 on the right. This one is going to be 6 times 1, which is 06 or 06. I'm going to go ahead to do this one next. 2 times 4 is 8. So I'm going to put that in as 08. 5 times 4 is 20. So I'll put that in as 2 and then 0. And then this one, 6 times 4 is 24. So that's going to be a 2 and then a 4. And then I'm going to add each of my diagonals here. So this diagonal is just a 4. 6 plus 2 plus 0 is going to be 8. 0 plus 5 plus 2 plus 8 is going to be 15. So I'm going to write my 5. And then I'm going to regroup my 1 in the next diagonal over. So now in this diagonal, I've got 0 plus 2 plus 0 plus the regrouped 1 is going to be 3. And then this diagonal is just a 0. And so since this is starting with a 0, I don't really need to write that. And my answer here would be 3,584.